Okay, so let us start our ionic equilibrium. Okay, so today we are going to see ionic equilibrium. Okay, it is one of the most difficult chapter from the student point of view, but believe me, this is one of the most easiest. Only the straight question will be a simple straight formula based. Okay, then why it is difficult? It is difficult because student don't know from in which question which formula will be asked. You don't worry. The entire chapter, what we will do, we will take the dabba. Whatever question they are asking, we will take the dabba and then we will add all the solution. Whatever solution they have given, right? We will take a dabba, we will mix all the solution in that. Clear? And then we will ask from the dabba what kind of acid you have, what kind of base you have, what kind of salt we have, and depending on the nature of the acid, base, and the salt, we will solve each and every question. Clear? So let's get started from the very first thing that you should know. What is acid? What is base? Okay. So first we will deal with the acid base concept. So we will study about the three acid base concept in this chapter, that is Arrhenius acid base, Lewis acid base, and then Bronsted acid base. Let us see here. So the first one is Arrhenius acid base theory. First one is sorry, Arrhenius acid base theory. Okay, so what is Arrhenius acid and what is Arrhenius base? So Arrhenius acid says that something which donate H plus ion. What is Arrhenius acid? Something which donate H plus ion. Where it will donate H plus ion? Where it will dissociate into H plus ion? Aqueous medium. Okay, those who donate H plus ion in aqueous solution, aqueous medium, as soon as you will take an acid and put it into a water, it will dissociate into H plus, and that is known as Arrhenius acid. What is our Arrhenius base? Arrhenius base is something which donate OH minus ion. What it will donate? OH minus ion. Where it will donate? Aqueous solution. In aqueous solution. Clear? So you take anything and then you just put it into water. If it is giving OH ion, means it is Arrhenius base. Clear? Let us see with one example. HCl. Okay, when we will mix with water, aqueous, it will dissociate. How it will dissociate? H plus aqueous plus Cl minus aqueous. So you see here, HCl is disintegrating into H plus now, means it is Arrhenius acid. Okay, let us see here one example, NaOH. So whenever you will put NaOH into water, what will happen? NaOH will dissociate as Na plus aqueous plus OH minus. Okay, so here NaOH is our Arrhenius base. So I hope it is clear what is Arrhenius acid and what is Arrhenius base. Let us move to the next topic, that is our Bronsted acid and base. I will just be in a corner, so everyone just note it down. Noted? Okay, good. Okay, so now we are going to see Bronsted acid and base. Bronsted acid and base theory. What is Bronsted acid and what is Bronsted base? Bronsted acid is something which donate H plus ion, in aqueous solution. Okay, what is base? Base is something which accept the proton, in aqueous solution. Are you able to understand? So Bronsted acid is that which donate H plus and Bronsted base is that which accept H plus. Very important. Clear? So from here, can I say that Bronsted acid and Arrhenius acid are same? Both are donating H plus, but Arrhenius acid donating OH minus, but Bronsted base is accepting H plus. Bronsted base is accepting H plus. See with an example. Any example you can take. Let's say for example, I am saying here H2SO4. So in aqueous medium, what will happen? It will disintegrate. Can I say it is disintegrating as H plus plus HSO4 minus. So it is giving H ion. So it is our Arrhenius acid also we can say, Bronsted acid also we can say. Let us see one example for our base NH3. NH3 when we will mix with water, it will become NH4 plus. See here, what is the difference? NH3 have taken one hydrogen. NH3 has taken one hydrogen. It has accepted one proton. Means here our NH3 is what? Bronsted base. What is NH3? Bronsted base. So I hope it is clear. What is Arrhenius acid base and what is Bronsted acid base? Now the third concept. Note it down, everyone. Okay, fine. Let us see the third concept. What is the third concept? The third concept is Lewis acid base concept. What is the third concept? Lewis acid base and concept. What is Lewis acid? Three keywords you have to remember. Someone which is electron deficient. Someone which is electron deficient. If I am deficient, if I don't have something, what I will do? I will try to accept it. So if I am electron deficient, I will accept the electron. So I am electron acceptor. And to accept something, I should have an empty stomach also, right? So, Lewis acid, three keywords. What are the three keywords? Electron deficient. And then as it is electron deficient means they are electron acceptor. And if they are electron acceptor, pakka they should have vacant stomach, that is vacant orbital, right? Ulta of this we will say Lewis base. Let us see here. Lewis acid, and here you write down Lewis base. So for Lewis acid, what will you say? They are electron deficient. If they are electron deficient, pakka they have vacant orbital. If they have vacant orbital, then only they can accept. Okay, and if they are accepting, so Lewis acids are electron acceptor. Lewis acids are electron acceptor. Now let us see here for Lewis base. What we will say for Lewis base? They are electron rich species. Okay. If they are electron rich, if I am rich, what I will do? I will donate. If I am rich, what I will do? I will donate, right? So here Lewis base are electron donor. Lewis base are electron donor, right? And they will have a lone pair. What they will have? Lone pair. Okay, so let us see the star. How will you identify in the question? Electron deficient, vacant orbital? You will confuse. So you remember one Nitya ma'am star point. Let us start from here. Okay. So what is the star point for Lewis acid? Boron family. What is the star point here? Boron family. You just see anyone from the boron family, pakka it is Lewis acid. Why? Because boron have 3 valence electron, so it will make 3 bonds. If it is making 3 bonds, so 3 into 6, 6 electrons. 6 electron is less than 8, na? If electron is less than 8 means it electron deficient. So entire boron family will make Lewis acid. So what is the star point? What is the trick here? No need to check electron deficient, vacant orbital, nothing. Just simply see. It is boron family. Boron, aluminum, gallium, anything. Boron family means it is Lewis acid. Simple. Similarly here, what is the star point? What is the trick here? See the lone pair. What will you see? See the lone pair. Okay. So, those who will have lone pair, they will behave as Lewis base. Generally, nitrogen we see generally, but oxygen and all will also have lone pair. So, you just see the lone pair. Yeah, note down. Okay, so let us solve some questions. Okay. Before we proceed to question, can we do a quick revision? Let us see. Okay. So what I have told you, 3 concepts I have told you. Arrhenius acid concept, then what I have told you. Bronsted acid concept, then what I have told you. Lewis acid concept. Arrhenius acid, what I have told you. Arrhenius acid and Arrhenius base. Then in Bronsted acid, Bronsted base. Then again in Lewis acid, Lewis base. These are the 3 cases I have told you. Okay. So Arrhenius acid, what is Arrhenius acid? Tell me fast. Those who can donate H plus. Who all are Arrhenius base? Those who can donate OH minus. Where they will donate? Aqueous solution. Where they will donate? Aqueous solution. Side by side, prepare short notes also. This should go in your short notes. Okay. How will you write down here? Anti star 1. Okay, so this is Nitya Tripathi ma'am first concept. Okay, so just write down in your short notes only these 3 keywords, that's all. Okay, so Bronsted acid, what I will say? H plus donate. Okay, Bronsted base, what I will say? H plus accept. Clear? Okay, Lewis acid, all the boron family bases, those who contain lone pair. That's all. Quickly remember here itself with me. So Arrhenius acid, donate H plus. Arrhenius base, donate OH minus. Bronsted acid, donate H plus. Bronsted base, accept H plus. Lewis acid contain all the boron family will behave as Lewis acid. Okay, Lewis base, those who contain lone pair. Fine. Let us solve some questions on these concepts. Okay, so the first question is, which of the following are Lewis acid? What is the first question? Which of the following are Lewis acid? So what is the trick I have told you for Lewis acid? Tell me fast. Lewis acid boron family. Lewis acid boron family. Lewis acid boron family. What is the trick here? Where is the boron family? Okay, boron. It is Lewis acid. Fine. pH 3. It is not from boron. Aluminum. Okay, boron. Silicon carbon family. Phosphorus. No. Silicon. No. Okay. Yes. Boron family. Boron. Aluminium also boron family. So what will be the answer? Fourth option. Easy or not? See the boron family. Boron family is Lewis acid. Let us see the next question. Identify the type of acid and base. So first CH3OH, what it is doing? It will donate H plus. Donate H plus means it is Arrhenius acid or Bronsted acid, whatever you want, you can say. Next here, NH3, it is accepting one hydrogen. Can you see? It is accepting proton acceptor. Proton acceptor means it is Bronsted base. Okay. HCl, it will donate H plus and Cl minus, right, in aqueous medium. H plus giving means it is either Arrhenius acid or Bronsted acid. Let us see the next one. NaOH. It will dissociate as Na plus and OH minus. OH minus giving, it is Arrhenius base. BaOH twice, again here it will dissociate as Ba2 plus and 2OH minus. It is giving 2OH minus, means it is our Arrhenius base. OH minus donation, Arrhenius base. H plus acceptor, Bronsted base. Okay. Cl3, we don't have here H plus or OH. So what does it mean? Pakka it will be Lewis acid or base. Boron family means it is our Lewis acid. Nitrogen, how many valence electron? 5. Out of 5, how many gone? 3. So 2 electron left out means 1 lone pair. Lone pair is present, means it is our Lewis base. So here we have finished the basics of acid and base concept. Okay. Okay, so let us see the next concept. So when you will see questions, then you will see so many words like this: monoprotic, diprotic, polyprotic acid, polyprotic base, monobasic acid, monoacidic base. What does it mean? Let us see here now. Okay, fine. So I am writing here this side for acid and this side I am writing for base. Okay, so if acid can donate 1 H plus ion, then it is known as monoprotic acid. It is known as monoprotic acid, or else we can say it as monobasic acid. What I can say here? Monobasic acid. Same way. Now you tell me fast. If it will donate 2H plus, what we will say? We will say it is diprotic. What we will say? It is diprotic. Or else what I can say? Dibasic acid. What I can say? Dibasic acid. Now you do by your own. If it is more than 2H plus, okay, more than 2H plus means 3H plus. 3H plus, what I will say? Triprotic, or else what I can say? Tribasic acid. So if more than 2, in general, what term we will use? We will say polyprotic acid. What I will say? Polyprotic acid, or else I can say here polybasic acid. Polybasic acid. Clear? So I hope it is clear. Monoprotic, diprotic, polyprotic. The same way we will say for base. So for base, what I will say? 1 OH minus, monoprotic base. 2 OH minus, diprotic base. 3, more than 2, polyprotic base. Let us write down here for base also. So 1 OH minus means what I will say? Monoprotic base. Monoprotic base, or else I can say here, so it is a base, so it will become monoacidic base. What will be the term? Mono. So you just have to focus on the last: acid, 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 diprotic, acid, acid, acid. So you just see the last term. The last term is acid, means we are talking about acid. The last term is acid, means we are talking about acid. Okay. Here, let's say for example 2OH minus. 2OH minus, what I will say here? What I will say here? Diprotic base. What I will say? OH, so base, diprotic to OH. Or else what I can say here? Diacidic base. What I can say here? Diacidic base. Similarly, if it is more than 2OH minus, what I will say? Polyprotic base or polyacidic base. Clear? Okay. So next you write down here the anti-star. Okay. So till now we have seen the first anti-star, that should go into your short notes. Okay. About the all the acids concept. Now the next second anti-star. You write down second anti-star. Okay. So in second anti-star you write down here H3BO3, H3PO2, H3PO3, H3PO4. So by seeing here 3 hydrogen, what our common brain will say? Our common brain will say that 3 hydrogen means it is triprotic acid. What our common brain will say? 3 hydrogen means it is triprotic acid. No, it is not like that. Keep it in your brain. Okay. So H3BO3 and H3PO2, even though it has 3 hydrogen, it is monobasic acid. Write down. It is monobasic acid. Monobasic acid or monoprotic. H3PO3, it is dibasic acid. H3PO4, it is tribasic acid, or else I can say triprotic, diprotic, monoprotic. So this should go into your star point, because from here the question will be asked, so you will make mistake. Mark my word, you will make mistake in your exam. Note down. Yeah, what you guys are saying? I'm hungry. I'm teaching since morning. I also get hungry, na bacha. Okay, these are the questions. So what I am asking here? I am asking here monobasic acid. What I am asking? Monobasic acid. Monobasic acid. Can we solve quickly? Just now I have told you for this oxy acids of phosphorus. Now one trick I am telling you. If in case you forget who was mono, who was di, who was tri, one trick you remember here. Okay. Even this point also, this trick also you add here in the anti-star, in the short notes you add here. For oxy acid of phosphorus, these are oxy acids of phosphorus. Oxy acids of phosphorus. For oxy acid of phosphorus, the number of H ion or number of OH bond will be equal to oxygen minus 1. The number of H ion will be equal to oxygen number minus 1. Oxygen number minus 1. What is the trick here? The number of H plus ion is equal to number of oxygen minus 1. Number of oxygen minus 1. Note down this also in your star point. Okay. Now let us solve the question. See here. So H3PO3. Okay. So how many oxygen? 4. 4 minus 1. It is 3 H ion, means it is triprotic. Triprotic, or I can say here tribasic acid. Okay. Here H3PO3. 3. So 3 minus 1 means it is dibasic. Easy or not? 2. 2 minus 1. Only 1 H plus ion. Monobasic acid. Third one, H3PO3 also I have told you, it is also monobasic acid. CH3CO minus H plus 1 H plus, it is also monobasic acid. Let us see here, HNO3 1 H plus, monobasic acid. H2SO4, it is bi or diprotic. HCl, it is mono. HCOH minus plus. Okay, so this is also our mono. HClO4, this is also our mono. So total how many mono? 1, 2, 3, 4, 5, 6, 7. So out of 10, total 7 monobasic acids are there. Over. So will you be able to identify all these monobasic, tribasic, protic, all those things? Okay. So let us move to the next concept. The next concept is very important. In the last 20 years, they have asked lot of question from this topic. Okay. So what is the next topic? The next topic is acid conjugate base pair and base conjugate acid. Yeah. With acid, what is coming? Conjugate base. And with base, who is coming? Conjugate acid. Let us study about these pairs. Note down fast. Okay, so let us start the next concept. What is that concept? Conjugate acid base pair, conjugate base acid pair. Okay, from it is clear that as from acid we will get conjugate base and from base we will get conjugate acid. Okay, so here I am writing acid conjugate base pair. The first concept is acid conjugate base pair. And let us take any acid. I have taken CH3COOH. Okay. So whenever we will mix it with water, what will happen? It will dissociate. Okay. So it will dissociate how? CH3COO minus plus H plus. Okay. Now you see here from an acid after removing hydrogen. From an acid after removing hydrogen, whatever you will get, that is our conjugate base. Easy or not? Very easy, right? So this is our acid, and from the acid after removing hydrogen, whatever you will get, that is our conjugate base. That is our conjugate base. Clear? Okay. Let us see the next concept. What is the next concept? Base conjugate acid pair. Base conjugate acid pair. So from the base we are getting conjugate acid. From the base we are getting conjugate acid. Okay, let us see here. Let us take any of the base. Let us see here I am taking NH3. So NH3, when I am accepting one hydrogen, in NH3 I am accepting one hydrogen, it will become NH4. It will become NH4. So in the base, after accepting the H plus, whatever you are getting, that is known as conjugate acid. That is known as conjugate acid. So what is the entire summary? First note down, then I will give you the NT star 3. Till now we have seen NT star 1, NT star 2. Now we will see NT star 3. Just to see the NT star 3 and you can solve any question of the conjugate acid base and pair. So from acid, when we remove H plus, what we get? Conjugate base. And from base, when we will add H plus, what we will get? Conjugate acid. Let us see. Over. Okay, fine. So you write down next. NT star 3. It should go into your short notes. It should go into your short notes. Acid. When remove one hydrogen. When remove one hydrogen, what I will get? Conjugate base. First star point. Second star point. Base. In base, when I add H plus, what I get? Conjugate acid. What I get? Conjugate acid. And how we will, this is the concept. Now how we will solve the question? We will solve the question with this 3 star point. See here. First star point, only one hydrogen, one proton difference should be there. Only one hydrogen, one proton difference should be there. So it is clear, whenever any question is asked from conjugate acid and base pair, what will you do? You will see the hydrogen ion. What will you see? You will see the number of hydrogen ion. If one hydrogen ion is missing, means pakka it is our conjugate acid base pair. If more than one hydrogen, means no, it's a worst option. Ignore it and go. That just like how you ignore your studies, nah? The same way you ignore that option and move to the next option. Okay. Next, 3 star point. If minus is there, if in any option negative sign is there means what? Hydrogen have been lost. It means what? Hydrogen have been lost. Then only an ion we will form. No. So minus means it is pakka, conjugate base. And from where conjugate base come? Conjugate base come from the acid. So whenever you will see minus, it means it is conjugate base. And conjugate base have came from the acid. Easy or not? Very easy, right? Next start point. Whenever you will see positive charge, what you will see? Positive charge means I have added hydrogen. Added hydrogen means it is conjugate acid. Conjugate acid have came from the base. Easy or not? Okay, fine. So let us solve the questions on conjugate acid base pair. Okay, let us see here. Note down question. Okay, fine. So let us solve the question. Okay, so what is the question? Identify conjugate acid base or conjugate base acid pair. So what I have told you, only the 3 star point. The first star point, see the hydrogen difference. What is the star point? See the hydrogen difference. If one hydrogen difference, then no stress, pakka it will be a acid base pair. Okay, if more than one hydrogen difference means it's a worst option. Cross it and go to the next option. Okay, let us see here. So here HCl one hydrogen, here Cl minus, no hydrogen, one hydrogen difference means it can be a pair. So I have told you minus charge means it is conjugate base, and pakka it should have came from the acid, means it is acid conjugate base pair, right? Okay, let us see the next question. Here NH3, 3 hydrogen, and here NH4, 4 hydrogen. How many hydrogen difference? One hydrogen difference means it is a base pair. How we will see here? So NH4 cation. Cation means it is conjugate acid, and conjugate acid will come from the base, means it is base conjugate acid pair. Easy or not? Try fast quickly. Solve 3, 4, 5 question by your own. Okay, now let us see here. Here OH3, 3, and here OH4. So one OH minus difference, only one proton difference only, right? So here it is minus means it is conjugate base, and conjugate base will come from the acid. So it is acid conjugate base pair, right? Okay, let us see the next question. NH2, NH3, one hydrogen difference. If one hydrogen difference means, yeah, it can be a some acid base pair. Let us see here. So it is cation. Cation means conjugate acid will come from base. It is base conjugate acid pair, right? Okay, let us see the next question. H2SO4, SO4 minus 2. So here hydrogen is 2, here hydrogen is here 2 hydrogen difference. So what I have told you, conjugate acid base pair will always differ by 1 proton. Keep it in your brain. Conjugate acid base pair will always differ by 1 proton. 2 proton. Wrong option. No. We will not see this. Waste of time. Okay, let us see here. 2 hydrogen, 1 hydrogen. Yeah, it can be possible. Minus means conjugate base. Base have came from acid. Acid conjugate base pair. Let us see the next question. 1 hydrogen, no hydrogen. 1 hydrogen difference means, yeah, it can be. And here it is minus means conjugate base came from conjugate acid. Acid conjugate base pair. Let us see here. 2 hydrogen, 1 hydrogen. Yeah, it can be some base pair. Okay, let us see. Minus conjugate base, and it have came from acid. So acid conjugate base pair. Let us see the next question. 2 hydrogen, dangerous. 2 hydrogen, but here no hydrogen. 2 hydrogen difference means it is the worst option. Leave it. Okay. So here we will say no, it is not an acid base conjugate acid base pair. 2 hydrogen, 1 hydrogen difference. Yeah, it is our. It can be minus means conjugate base came from acid. So acid conjugate base pair. Let us see the next question. Let us see the next question. H3. H. How many hydrogen difference? 2 hydrogen difference. I have told you, na. It is worst option. Hydrogen should be only 1 hydrogen difference, right? Worst option. Move to the next. H3PO4. Very bad. Very worst option. 3 hydrogen difference. 1 hydrogen difference only, right? Just waste of time. Here 3 hydrogen, 2 hydrogen. Yeah, we can check it. So minus means conjugate base have came from acid. Conjugate base acid pair. Let us see here. 2 hydrogen, 1 hydrogen difference. Yeah, it can be. Minus means conjugate base always come from the acid pair. So here we have learned How to solve conjugate acid base pair or conjugate base acid pair within fraction of seconds. What are the three keywords you have to keep in your brain to solve these questions? First start point, only one proton difference. Minus means it is conjugate base acid pair. Plus means it is conjugate acid base pair. That's all. Let us start the next topic, that is electrolytes. Okay, so we will study basically about this topic in our 12th standard in detail. Now here we will just know what is electrolyte and what are the types of electrolyte. Okay, so what is electrolyte? You take anything, you take any compound, okay, and then you just put it into water. You take any compound and you just put it into water. If it is dissociating into cation and anion, if it is dissociating into cation and anion, that compound will be known as electrolyte. Clear? So what is electrolyte? Any compound, if we are putting it into water, it dissociates, it ionizes into cation and anion. That particular compound is known as electrolyte. So electrolyte means it will dissociate in aqueous solution. It will dissociate in aqueous solution. Okay. Now electrolytes are of two types. Electrolytes are of two types. What are these two types of electrolyte? Weak electrolyte and strong electrolyte. Weak electrolyte and strong electrolyte. Okay. Weak electrolyte are those who undergo partial ionization. It undergo partial ionization, or else I can say partial dissociation. Partial ionization or partial dissociation. What does it mean? It means that weak electrolyte, when we will put into water, weak electrolyte, when we will put into water, it will not dissociate completely. Not all the ions will dissociate. Some ions will be present in the compound itself. Not everything will dissociate. That is known as partial dissociation. Okay. Next, strong electrolyte. Strong electrolyte means the one who will undergo 100% dissociation. Strong electrolyte are those who undergo 100% dissociation. Means completely dissociate. You will put it into water, it will dissociate. You will put it into water, it will dissociate. How much? 100%. Completely it has gone into cation and anion. That is known as strong electrolyte. Clear? So for weak electrolyte, the degree of dissociation alpha will be less than 1. Why? Because it is not 100% dissociating. It is partially dissociating. So alpha will be less than 1. Here for 100% dissociation, alpha will be equal to 1. For 100% dissociation, alpha will be equal to 1. 100% dissociation, alpha 1. Not 100%. Partial dissociation, alpha less than 1. Clear? Okay. Now let us see here examples. Let us see here example of weak electrolyte and strong electrolyte. Weak electrolyte, all the organic acid. All the organic acid, in short I will say weak acids. Okay, all the organic acid, weak acids are the example of weak electrolyte. Let's say for example CH3COOH. How will you identify organic acid? COOH, carboxylic group. COOH, carboxylic group will be there. HCOOH, or else I can say on the head of the benzene COOH. What I can say on the head of the benzene? COOH. Okay, let's say then oxyacids of phosphorus. For example H3PO4, H3PO3, H3PO2. Okay, all these are also our weak acids. Clear? Next example is our weak base. Okay, what are the weak bases? Those who contain nitrogen. Those who contain nitrogen, like NH4OH. Like NH4OH are known as our weak base. Clear? Now let us see here some examples of strong electrolytes. So strong electrolytes, strong acid and strong base and salt. What are the example of the strong electrolyte? Strong acid, strong base and salt. Strong acid, strong base and salt. Strong acid example will be like HCl, HClO4, H2SO4, HNO3. Okay, these are very important here. You can write on one more. HNO2 is our weak acid, but HNO3 is our strong acid. Clear? HCN is also our weak acid. You have to remember all these types, then only we can solve the questions of ionic equilibrium. Clear? Strong base, all S block elements like NaOH, KOH, okay, BaOH twice, na? These all are the example of our strong bases. And salt like NaCl, okay, Al2SO4 thrice. All these are the example of our strong electrolyte. Okay, now let us see the next topic, that is ionic product of water. What is the next topic? Ionic product of water. From the name is clear, they are saying ionic product. It means let us break down water into some ions. Okay, let us break down. So we will break down here water. So what we will get? H plus ion and OH minus ion. What we will get when we will break the water? H plus into OH minus ion. Let us write down the K equilibrium. Equilibrium constant for it. So we know K equilibrium is equal to product by reactant. We all know that product by reactant. What is product here? Concentration of H plus into concentration of OH minus divided by reactant concentration of water. Any problem? No. And we know that water is pure liquid. Here water is pure liquid. So for pure liquid, concentration will become 1. We will ignore pure liquid, pure solid. So what will be K equilibrium here? K equilibrium will be equal to H plus into OH minus. So ionic product is nothing. The product of ions of the reactant. The product of ions of the reactant. So reactant is water. Water is going into H plus OH minus. So product of H plus and OH minus is ionic product of water. As it is ionic product of water, so we will replace this Kw by the term K equilibrium by the term Kw. So for water, what term we will use? Kw. So what is Kw? H plus into OH minus. What is Kw? Tell me fast. H plus into OH minus. Clear? Note it down fast. I'm standing in a corner, note it down. So ionic product of water is what? Kw equal to H plus into OH minus. Okay. Now, write down important star point at 25 degrees centigrade or 298 Kelvin. Kw is equal to 10 to the power minus 14. What is the value? You have to remember it. Okay. So at 25 degrees centigrade or 298 Kelvin, Kw is 10 to the power minus 14. We know that from the reaction, H plus ion is equal to OH minus ion. So can I say here that H plus ion is equal to OH minus ion, and that will be equal to how much? 10 to the power minus 7. So what are the two star points you have to keep in your brain? Ionic product of water at 25 degrees centigrade is 10 to the power minus 14, and the concentration of H plus ion and OH minus at 25 degrees centigrade is 10 to the power minus 17. Why? Because H plus and OH ion concentration will be equal. According to the reaction we have seen, the H2 is going into 1 H plus 1 OH minus. I am asking you a simple statement. Okay, the statement is pH of water will be always 7. What is the statement? That pH of water is always 7. Is it true? Always? No, it is not true. Don't make this mistake. I will tell you how. So you write down here as a star point, Kw only depends on temperature. Kw only depends upon temperature, right? So temperature is the only factor which can affect our Kw. Let us see how. So note down the next heading, effect of temperature on Kw or the pH of water. Now let us see here the effect of temperature on the pH. Effect of temperature on the pH. Okay, so I am writing here effect of temperature on pH. Effect of temperature on pH. Okay. So write down here at 25 degrees centigrade pH of water. First let us calculate at 25 degrees centigrade pH of water. How we will calculate? Tell me fast. So we know at 25 degrees centigrade Kw is 10 to the power minus 14.
So from here H ion is equal to 10 to the power minus 7. So pH is equal to minus log H plus ion. Okay, so minus log 10 to the power minus 7. So minus 7 minus plus. So pH is equal to how much? 7. Clear? So at 25 degrees centigrade, what is the pH of water? 7. So if I am drawing a pH scale here, 7 is our neutral point. 7 is our neutral point. pH of water is 7. So if it is less than 7, so I will say they are acidic in nature. In childhood we have studied, right? pH more than 7 means I will say it is basic in nature. Clear? Okay. Now let us see what if we will change the temperature. Let us see when I am increasing temperature, when I am decreasing temperature, what is going to happen. Okay. So second case, write down here, if temperature more than 25 degrees centigrade, if I am increasing the temperature more than 25 degrees centigrade, if temperature is increased, what will happen? Dissociation of water. Dissociation of water will increase or not? It will increase, bacha. More temperature, more water will dissociate. So dissociation will increase. When dissociation will increase, so H ion or OH ion, both concentration will increase. When H ion, OH ion will increase, so the product of H plus and OH minus ion will also increase, and we know product of H ion and OH ion is Kw. So from here I can say Kw will also increase, that will become 10 to the power minus 14. Why? Because at 25 degrees centigrade, Kw was 10 to the power minus 14. So more than temperature 25, Kw will be more than 10 to the power minus 14. If Kw more than minus 14, so from here I can say H plus ion will also more than 10 to the power minus 7. 10 to the power minus 7. When H ion is more than 10 to the power minus 7, so we know simple pH will be also. So we know simple basic math from here. If H ion is more than 10 to the power 7, so pH will become less than 7. pH will become less than 7. Now you tell me, whenever I am increasing temperature, dissociation increases, H ion increases, OH ion increases, Kw increases. So when KWH ion increases, pH will decrease. What will be the case third? Before I am writing here, you should start solving. You should do it by yourself. Then only you will learn, right? So case third, tell me fast. What will you write down? For case third, you will say if temperature less than 25 degrees centigrade. So what will happen? Dissociation. What will happen? Dissociation will decrease. So what will happen? H ion concentration, OH ion concentration will decrease. When H ion, OH ion concentration will increase, so the ionic product Kw will become less than 10 to the power minus 14. When Kw is less than 10 to the power minus 14, means H ion will become less than 10 to the power minus 7, means pakka pH basic calculation. pH will become more than 7. Okay, so if I will draw a pH scale here, okay, let's say 7 here. So they are saying this time the neutral point is less than 7. The neutral point is less than 7. So somewhere here is our neutral point. So here 7 will become basic. So from here what you can say, what you can conclude, that at 25 degrees centigrade the pH of water was 7. The pH of water was 7. 7 was our neutral point. So less than 7 acidic, more than 7 basic. 7 was neutral. When we increase the temperature, KH increased, Kw increased, H ion, everything will increase. When everything is increased, H ion increased, so pH decreased. So when the pH is less than 7, now the neutral point is less than 7. So what does it mean? So let's say for example it is 6.8. So 7 will become basic. Clear? Third case, what we have seen, when the temperature is decreased, so H ion decreased. When H ion has decreased, means pH have increased. Now we are getting neutral point something around, for example 7.5 or 8. For example 8 is our neutral point. So this time 7 will become acidic. Have you ever thought that 7 will become acidic? When the temperature is changing, so the pH will also change. So the question is, if Kw is 10 to the power minus 12 at temperature T, then find the nature of these solutions. Okay, so you will not say, ma'am, pH 7, so it is neutral solution. No, see what is given at a temperature T, some specific temperature they have given. I have told you when temperature will change, pH may change. Okay, and what is a Kw here? Tell me fast. Kw is 10 to the power minus 12. So from here I can say H ion will be how much? 10 to the power minus 6. So the pH of water will be how much? 6. The pH of water will be how much? 6. So here in this case the neutral pH is 6. In this case 6 is our neutral pH. So now tell me fast, more than 6 it will become basic, less than 6 it will become acidic. Okay, so let us solve here. Let us find out the nature of this solution. pH 7, more than 6, more than 6, pH 7 here, not neutral, here it is basic. 5.9, less than 6, so here it is our acidic. 6.3, more than 6, so this is also our basic. Now I hope it is clear how to find out the nature of the solution if Kw is given at any specific temperature. Okay, now let us solve one more question on this concept. So do it fast quickly. So Kw is equal to 10 to the power minus 16. So I can write down here Kw equal to 10 to the power minus 16. So what will be H ion here? H ion over H ion equal. So it will become 10 to the power minus 8. So directly I can say pH will be equal to 8. You will not use formula minus log H ion for this simple question. pH directly 8. So 8 is our neutral point. Kw aeration constant of water. So pH of water, neutral pH is 8. So from here more than 8 will become our basic, less than 8 will become our acidic. Okay, let us solve fast. So 6.8 is less than 8, means it is acidic. 7.2 less than 8, this solution also acidic. 8 means it is our neutral pH. Okay, 8.3 more than 8 means it will become our basic. Are you able to understand? So don't directly write on pH 7 means neutral. No, it will change if the temperature is changing, because Kw will change. So H ion will also change. Clear? Now let us solve one more question here. So in a container at a temperature T, H ion is 10 to the power minus 7 and OH is 10 to the power minus 3 molar. Okay, so if H ion, OH ion is different means pakka, they are not talking about water, right? Okay, if we increases the H ion, so H ion is increased to 10 to the power minus 5, then what should be the OH minus ion? What should be the OH minus ion at a temperature T? So temperature is same, means from here I can say the Kw will be constant. So whatever is the Kw for that case, the same Kw will be for this case also, right? Okay, so can I find out Kw? So how will you calculate Kw? Kw is equal to H ion into OH minus ion. How much H ion given? H ion is given 10 to the power minus 7 into OH ion is given 10 to the power minus 3. So from here Kw I can say it is 10 to the power minus 10. So we know Kw will be constant because temperature is constant. So from here what I can say? From here I can say that Kw equal to, for the second case I am using this formula now, H plus into OH minus Kw, how much we have got? 10 to the power minus 7. In the case second, H plus ion they have increased to how much? 10 to the power minus 5 into OH minus ion. So from here OH minus ion will be equal to how much? 10 to the power minus 10 by 10 to the power minus 5, that is 10 to the power minus 5 molar concentration. Okay, now let us see some important relations which you have to remember as it is. Okay, write down next heading. Some important relations. Some important relations. Okay, so we will keep all these relations as it is in our brain to do easy and quick calculation. I am not giving you the derivation of anything because it is a one shot series. Okay, so first relation you write down, relation between Ka, Kb and Kw. Ka, Kb and Kw. So from here you write down Ka into Kb is equal to Kw. What is Ka and Kb here? So write down Ka is dissociation constant of weak acid. So what will be Kb here? Dissociation constant of weak base, or else I can say it is a dissociation constant of conjugate base. Okay, so I have taught you how to find out conjugate acid and base. Clear? Okay, so this relation is very important. Now you tell me, at 25 degrees centigrade, what is the value of Kw? I have taught you. Kw is equal to 10 to the power minus 14. So can I say one more relation from here, that Ka into Kb is equal to 10 to the power minus 14 at 25 degrees centigrade, because K into Kb is Kw, right? This is our first relation, this is our second relation. Clear? Now some small general whatever we have studied, I will just write down as a summary. Okay, now third, if I have given H ion concentration, so from here what I can find out? pH. Okay, what will be pH here? pH will be equal to minus log H plus ion, right? Okay. Fourth, let's say for example, if I know OH minus ion, if I know OH minus ion, so from here what I can find out? POH. Very good, you are correctly thinking. H ion means I can find out pH. If OH minus means we can find out POH. So POH will be equal to minus log OH minus ion. Okay, now here the fifth. Okay, so if I know pH and pOH, can I write down it like this? Can I write down? We know H plus ion into OH minus ion is equal to Kw, and that is our 10 to the power minus 14, right? So can I write down H plus ion as pH and OH minus ion as pOH? We can write down. So can I get the sixth relation here? pH plus POH is equal to 14. Can I get it like this? pH equal plus POH is equal to 14. Very important relation. Why? You write down here as a star point when we will use it. If base is given, if base is given and pH is asked. If base is given and pH is asked, so what I will do? If base is given, first step I will find out OH minus ion. After calculating OH minus ion, I will find out POH. Okay, and after calculating POH, the third step what I will do, I will put this into pH equation. Third step what I will do, I will put it into this equation, and from here I will get pH equal to 14 minus POH. Are you able to understand? Very important. If base is given and they are asking you the pH, you cannot, okay, OH ion is 10 to the power minus 6, so ma'am pH is also 6. No, we can't say that OH ion na bacha, OH ion. So from OH what we will get? POH, and from POH we will use this relation pH plus POH equal to 14, and then we will get our pH. So keep this in your brain. Okay, so this is our sixth relation. Same way I can write down it for Kw and Ka also. Let us see how. Can I write down it like this? If I have Ka, so what I can find out? Yeah, you are thinking right. We can find out pKa, that is 10 to the power, like that is minus log Ka. Same way, if I know Kb, so what I can find out? pKb, same formula, minus log Kb, right? So from here, if I got pK and pKb, can I write down our eighth relation? That is what we know. Kw into Kb is equal to 10 to the power minus 14. We are talking about at 25 degrees centigrade. If I am writing 10 to the power minus 14. So from here I can say pKa plus pKb equal to 14. I can say from here pKa plus pKb is equal to 14. Just these are the 7 to 8 relations I have written. Keep it in your brain, then ionic equilibrium will become very easy for you. Okay, let us solve some questions. Okay, so let us solve one question. What is the question? At 90 degrees centigrade, pure water has H3O plus has 10 to the power minus 6. H3O plus is nothing but H ion only. So what they have given in this question? H ion value is given 10 to the power minus 6. H ion is given 10 to the power minus 6. So we will use the relation. Which relation we will use? H ion given Kw asking Kw equal to 10 to the power H plus into OH minus ion. And we know for pure water H ion and OH ion are equal. For pure water H ion is equal to OH minus ion. So 10 to the power minus 6 into 10 to the power minus 6. So we will get here 10 to the power minus 12 Kw. Easy? Yeah, if H ion is given 10 to the power minus 6 from here, if they have not asked, can I calculate pH also? pH equal to minus log H ion, 10 to the power minus 6, so pH will become 6 for this question. Fine? Okay, so let us solve next question. Given HF plus H2 is going into H3O plus F minus. So HF, F has given one proton, means it is our acid, right? So acid means K is already given. Even though if not given also, we know it is K. Okay. Then F minus is accepting one proton to become HF, means F minus is our conjugate base. We know whenever we remove H plus, whatever is remaining conjugate base, I have already taught you, right? So F minus HF. Okay. Now from here, which of the following are correct? So we know they are asking you the relation between Ka and Kb. Array, we know, just now I have told you what I have taught you. Ka into Kb is equal to Kw. Which option? Second option is correct answer. Clear? Okay, let us solve the next question. If pKb for fluoride ion at 25 degrees centigrade is how much? 10.83. pKa for hydrofluoric acid in water at this temperature is, so temperature is same. What they are asking? pKa. What they have given? pKb. So just now I have taught you one relation. Even though if you don't remember also, we know Ka into Kb is equal to 10 to the power minus 14. So from here pKa plus pKb is equal to 14. Always star point. 25 degrees centigrade is mentioned. That's why I am directly writing here 14. Clear? So what they are asking? pKa. So pKa will be equal to 14 minus pKb. So 14 minus pKb is how much? 10.83. How much we will get here? 3.17. What will be the answer? 3.17. Okay, so let us see the next topic, that is pH calculation. Okay, now we are going to study the next topic, that is pH calculation. Okay, so in this pH calculation, we will solve how many cases? We will see strong acid pH, then we will see strong base pH, then we will see the mixture of strong acid with strong acid, then we will see the mixture of strong base with strong base, then we will see the mixture of strong acid with strong base. After that we will see weak acid, then we will see weak base. After that what we will see? The mixture of weak acid with weak acid, then we will see mixture of weak base with weak base, then after that we will see the mixture of weak acid with weak bases. So how many types of question we are going to see? These are the types of question that we will see for the pH calculation topic. Okay, let's get started. So note on the first heading, the first topic, pH calculation for, write down the case 1. The case 1, pH calculation for strong acid. pH calculation for strong acid. Okay, so whenever I am talking about strong acid, we will have two cases. Whenever I am talking about strong acid, again under this case also we will have two cases. What are these two cases? You have to keep in your brain that H plus ion either greater than 10 to the power 6 molar or H plus ion less than 10 to the power minus 6 molar. So what are the two cases? H plus ion more than 10 to the power minus 6, H plus ion less than 10 to the power minus 6. Clear? Okay, now see here. If H plus ion is more than 10 to the power minus 6, means 10 to the power minus 1, minus 2, minus 3, minus 4, minus 5. Now these all are the cases of more than 10 to the power minus 6. Clear? Okay. And more than less than 10 to the power minus 6 means minus 7, minus 8 and so on. Clear? So when the H ion concentration is greater, when the ion concentration is greater. Okay, so as comparison to that, the ion of water will be very less. The ion of water will be very less. So whenever H plus ion is more than 10 to the power minus 6, what is the star point here? Ignore H ion concentration of water. We will ignore the H ion concentration of water. So what I have told you, whenever our H ion is more than 10 to the power 6, we will ignore the water H ion concentration because acid H ion is more. Okay. So here the concept, the formula will be here. The H plus ion total, here the H plus ion total will be equal to H ion of acid, will be equal to H ion of acid. We will ignore the H ion of water. Okay. Here in the second case, H ion concentration is less than 10 to the power minus 6. Okay. So whenever H ion concentration is less than 10 to the power minus 6, so here we will consider H ion of acid as well as H ion of the water also. So here the star point is consider water H ion also. Consider water H ion also. When H ion of acid, I am writing here so it will be more clear for you. H ion of acid more than 10 to the power minus 6, ignore water H ion. Answer will be only H ion acid. But if H ion is less than 10 to the power minus 6, we will not ignore the H ion of water. In that case, what we will do? What will be the formula? In that case, the total H plus ion will be equal to H plus ion of acid plus H plus ion of water. Okay, so H plus total will be equal to H ion of acid plus, what is the H ion of water? We all know 10 to the power minus 7. 10 to the power minus 7. So what are the two star points you have to remember for strong acid? We have two cases, H ion greater than 10 to the power minus 6, H ion less than 10 to the power minus 6. If H ion is greater than 10 to the power minus 6, total H ion equal to H ion of acid. But if H ion is less than 10 to the power minus 6, then in that case, total H ion will be equal to H ion of acid plus 10 to the power minus 7, that is H ion of water. Clear? How we will find out pH for this? We know the simple formula. Here also pH will be equal to minus log H plus ion, and here H ion will be equal to H ion of acid. Clear? In this case, how we will find out our pH? pH will be equal to minus log H ion total. It will be our H ion of acid plus 10 to the power minus 7. Only these are the two star point you have to keep in your brain. If concentration is more than 10 to the power minus 6, simple formula, easy question. If concentration is less than 10 to the power minus 6, then also not a big deal, just add 10 to the power minus 7, that is the H ion of water, that we will not ignore. Clear? Let us solve one question and then we will understand the next. We will go to the strong base. Okay, so you remember, before we proceed to the base, we will remember one star point. The star point is, after calculating H ion concentration, check the number of hydrogen in the acid. Number of hydrogen in the acid. What does it mean? Let's say, for example, I am taking HCl. So here H ion concentration, whatever we have calculated. But if I am saying H2SO4, here we will not write down H ion, whatever we have calculated. Here we will say 2 hydrogen na bachcha. So we will multiply by 2 into H plus ion concentration. Are you able to understand? This is the trick here. This is the star point here. Here only you guys are going to make mistake. Okay. Now let us solve one question. Okay, so let us solve this question. Calculate the pH of the following acid. So whenever you are seeing ionic equilibrium question, first you check what it is, given acid or base. Okay, once you are checked. Once you have checked either it is acid or base, then you check it is strong acid, strong base, weak acid or weak base. Accordingly, we will apply our concept and the formula. So let us see here H2SO4 acid. Which acid? Strong acid. Already I have taught you in the starting of the chapter. Okay. So what is the concentration? 0.1 means 10 to the power minus 1, and 10 to the power minus 1 is greater than 10 to the power minus 6. So easy or difficult question? Easy question, simple question. Directly here I will say the H ion total is equal to H ion of the acid. What is the H ion of the acid? 10 to the power minus 1. So what will be the pH? pH will be equal to minus log H plus ion. So minus log H ion is 10 to the power minus 1. Minus 1 will come here, minus minus plus 1 log 10, and log 10 is 1. So pH will be equal to 1. Will you do this much? No. What is the power? Minus 1. 1 is the pH. Power is 2. pH is 2. Power is 3. pH is 3. Whatever is the power, that is our pH. Will not solve this much. Clear? Now here you have made mistake. Not only you, 99% student will make mistake. They will see only H ion. No, what is the star point? If you will do like this, it's a wrong method. It's a wrong question. You don't have to do like this. Can anyone tell what mistake I have done here? Yeah? What mistake I have done here? Very good. H2, bacha. What mistake I have done here? H2, 1 molar, H2SO4. H2 is here, 2 ion. You forget to multiply by 2 here. Clear? Okay, let us solve here. Let us solve here. H2SO4, 2 ion. Don't forget. Okay. So here how we will solve. So our H ion will be equal to 10 to the power minus 1 into 2, because here 2 hydrogen. Okay, and I will tell you one very simple technique to solve log value. One is minus log 2 into 10 to the power minus 2, or simply I will tell, whenever you will see like this, whenever you will see H ion as 2 into 10 to the power minus 1, in this term directly you will calculate pH equal to whatever is the power, that power you bring first. So it will come as 1 minus 1 minus, and whatever is the first number, that will come as a log. It will become 1 minus log 2. Clear? So here it will become 1 minus log 2 is 0.3. So answer of pH here is 0.7. Are you guys able to understand? Whoever will give answer pH 1, it will be wrong, because here it is H2SO4, 2 H ion. Fine. Now here HCl, here 1 hydrogen only, directly we will do. So we'll see here H ion. What is the H ion here? What is the H ion here? 10 to the power minus 12, and it is less than 10 to the power minus 6. So what I will say here, ma'am, it is not that simple. We have to add 10 to the power minus 7 here, right? So here what will be the H ion? Here H ion will be equal to 10 to the power minus 12 H ion of acid plus 10 to the power minus 7 H ion of water. So here it will become, let us take 10 to the power minus 7 common. So it will become 10 to the power minus 5 plus 1. Okay. So 10 to the power minus 5 means 0.00001. Okay. So how we can write down here? 1 plus 10 to the power minus 7 here. 1 plus 0.00005. Fine. Sorry. Here it will become 0.001. Okay. So here we can say 1. So it will become 1.00001 into 10 to the power minus 7. Any problem? No. Okay, now let us solve here pH. So what I have told you, what is the trick I have told you to for pH? Whatever is power, 7 will come here, and minus log whatever is our first number, 1.00001. So 7 minus, what is the value of log 1? 0. But it is greater than 0, greater than 1. So the value will be little greater than 0. So can I say, let's say 0.1. So what will be the answer here? 6.99. Okay, now let us see the case 2. Okay, note down case 2. What is case 2? Strong acid over. We will calculate pH of strong base. We will calculate pH of strong base. So for strong base also we will see the two cases what I have told you. If OH, so base na, so base will not calculate H ion. For base what we will calculate? OH minus ion. So if OH minus ion is more than 10 to the power minus 6, if OH minus ion is less than 10 to the power minus 6, okay. If it is more than 10 to the power minus 6, no tension. What I will do, I will say here OH ion will be equal to number of OH ion from the concentration of OH ion from the base. And if we have 1 OH ion multiply by 1, 2 OH ion multiply by 2, like that we will say, okay. Now here after OH ion directly don't say, ma'am, if OH ion is 10 to the power minus 4, so pH will become 4. No, it is OH. pH is 10 minus log H ion, na? So it is OH, but I want H ion. So important. Once I have for base, first we will calculate OH ion. After calculating OH ion, we will calculate H ion. How we will calculate the OH ion? Tell me first. Either you calculate OH ion or else what you do? You calculate POH. Okay. From OH, what I will calculate? POH. What will be POH? Minus log OH minus ion. And after calculating pH, POH will calculate pH, that is 14 minus log POH. For this day only I have given all these relations now. So in case of base, what is the star point? Base means OH ion given. OH ion means calculate POH. POH, after calculating POH, we will calculate our pH. So next case is when OH ion is less than 10 to the power minus 6. When OH ion is less than 10 to the power minus 6 means we will not ignore water, right? We will not ignore water. So here in this case, OH minus ion total will be equal to OH minus ion of the base plus 10 to the power minus 7. Why? Because from water, OH ion is 10 to the power minus 7 only. Clear? Now here also from OH what we will calculate? POH. From POH what we will calculate? pH. Simple. So the simple thing, either strong acid, strong base, just check the concentration. Concentration more than 10 to the power minus 6. Simple question. Okay, no need to add anything. But if concentration less than 10 to the power minus 6, add 10 to the power minus 7. From where it is coming? It is coming from the water. For conceptual knowledge, for in-depth knowledge, why we are doing this, why we are not doing this, to know the reason behind it, that why only we are adding 10 to the power minus 7 in this case, but here we are not getting, here we are not adding. To know all this conceptual in-depth clarity, you should join my full-fledged course. So that is either you can join online classes or you can join offline classes in my Pondicherry center to know the in-depth knowledge of chemistry, how, where, when. It will give you next level of clarity. So from there you can even solve most difficult type of question of JEE Main, JEE Advanced, any kind of question you will be able to solve. Okay, now let us solve one example also, so that we will get little more confidence on this topic. Okay, which twice. Clear? Okay. Now let us solve here. So first you will identify either it is acid or base. NaOH, OH means it is base. Okay. So base, now you will see strong acid, strong base, whatever it is. Okay. So it is strong base. Okay. So strong base. First step, check the acid base. Second step, check the strength, as strong or weak. After that, check the concentration. So NaOH. So OH concentration is given here. How many zeros? 1, 2, 3, 4. Okay, 4 decimals. So OH ion is 10 to the power minus 4 molar. Now tell me, minus 4. Next step we will check. Minus 4 is more than 10 to the power minus 6 or less than? So minus 4 is more than 10 to the power minus 6. So means it's our easy reaction. Easy reaction, easy question. Okay, so here I can directly say my OH ion is 10 to the power minus 4. No need to add water, because it is more than 10 to the power minus 6. So OH is this. So POH directly can I write down? I will not solve. What is the power? 4. POH will be 4. So what will be pH? pH equal to 14 minus POH. That is 14 minus 4. So pH will be 10. And it is right also. Base na bacha. Base pH will come more than 7. Base pH will come more than 7. 10. It is right answer. Now let us see here. BaOH twice. Now what the students will do? They will say, ma'am, those who have not studied from Nitya ma'am, those who don't have conceptual clarity, what they will do? Ma'am, OH is 10 to the power minus 8. Minus 8 means POH will be 8. So 14 minus 8. 14 minus 8 you will do, it will come less than 7. It will become acidic. No. Here it is base, na? pH should come more than 7. So we will use some common sense also while seeing the option. Clear? Okay, now see here. So we will check it is base, but here danger sign 2 to OH. Don't forget to multiply by 2. Okay. Now here OH how much they have given? Here OH minus is given as 10 to the power minus 8, which is less than 10 to the power minus 6. So it is little dangerous. Real dangerous question. How we will solve it? Simply, we don't have to take much stress. We will just add here 10 to the power minus 7. But before adding, we will multiply by 2. Why? Because 2 to OH ion. So from base, we will get 2 into 10 to the power minus 8 plus 10 to the power minus 7. Now from here, OH minus ion will be equal to, let us take 10 to the power minus 7 common. So it will become 2 into 10 to the power minus 1 plus 1. So from here OH ion will be equal to 10 to the power minus 7. 2 into 10 to the power minus 1 means 0.2 plus 1. So here OH minus ion is equal to, we can say 1.2 into 10 to the power minus 7, right? Okay. Now, how we will calculate the POH from here? So, from here POH will be equal to, I have told you, whenever it is in the multiplication form, the power will come here 7 minus log, whatever is the first number before multiplication, log 1.2. So, from here I can say 7 minus log 1 value is 0. So 1.2 means little greater than 0. Can I say, let's say for example here also I am taking 0.1. So can I say here my POH is coming 6.9. For example, my POH is coming 6.9. So what will be my pH? My pH will be 14 minus 6.9. 14 minus 6.9. How much it will come? Do it fast, quickly. Fast, quickly. So 14 minus 6.9. How much it will come? 7.1. Yeah, it should come also. Correct, right? Why it should come more than 7? Because we have taken base, right? So I will tell you the short trick for this. No need to do this much calculation also. Whenever, write down it as a star point. Write down it with a red pen. Okay, whenever H ion is less than 10 to the power minus 6, see the option, pick that option which has pH less than 7, because I said so it will be less than 7, close to 7, 6.98, 6.99, like that it will come. The same way, if base is given and the concentration is less than 10 to the power minus 6, same way the pH will come more than 7 plus close to 7, 7.1, 7.2, like that. Easy. So no need to do this much of calculation. Okay. So now let us see the next topic. What is the next topic? Case third. So case 1 we have done strong acid. Case 2 we have done pH of strong base. Now we are going to see mixture. Okay. Mixture of strong acid, mixture of strong base. So case 3, pH of mixtures. pH of mixtures. Okay, now in that case we will see again two cases. One side we will see mixture of strong acid, strong base. No, first let us see strong acid mixture, same, strong base and strong base mixture. Clear? Okay, so how we will do? So there is a mixture of two things, right? So what we will do? We will calculate. We will see H ion of this, we will see H ion of this. After seeing, as they are both acid, they will not react. They are both base, they are not going to react. So we can't subtract it, right? So as both are acid, both will contribute H ion, so we will add. Both are base, both will contribute OH ion, so we will add. Clear? So both will give H ion, so we will add total H ion. So if this H ion value is same thing, sorry, today I am not well. Okay, so if this H ion value is greater than 10 to the power minus 6, say we will ignore 10 to the power minus 7, and if it is less than 10 to the power minus 6, what we will do? We will add 10 to the power minus 7. That is our normal common thing which I have taught you already, because we are talking about strong acid, right? After that, what we will do? We will calculate net H plus ion, total H plus ion, total H plus ion of mixture. Here is the key word. So how to calculate total H ion of mixture? Total H ion of mixture is equal to net mole of H plus ion by net volume. Net volume, it means total number of mole of H ion by total number of volume. Total number of mole of H ion by total number of volume. Okay, now here for base, what we will do? Base also same. I will find OH ion from here, OH ion from here, then we will check either it is more than, this OH ion is more than 10 to the power minus 6, or it is less than 10 to the power minus 6. More than 10 to the power minus 6, no stress. Less than 10 to the power 6, we will add 10 to the power minus 7. After that, what we will do? We will calculate here total OH ion. Total OH ion will be equal to net mole of OH ion by total volume or net volume. Here we will calculate OH ion net. Here we will calculate H ion net. Okay. After that, if after calculating H ion, we will calculate our pH directly, no stress. Here OH ion we have calculated, so directly we can't calculate. What we will do? From OH we will calculate POH, and from POH, okay, after calculating POH, what we will calculate? pH. What is the formula? pH equal to 14 minus POH. Everything is clear? Fine. Now you should know how to calculate mole. So every time concentration will be given, volume given, molarity given. So we know molarity is equal to mole by volume in liter. So from here I can say that mole will be equal to molarity into volume in liter. So how will you calculate the mole? Molarity into volume in liter. Molarity into volume in liter. That's all. Can we solve the question? Let us solve questions. Okay, fine. So let us solve this question. So see here, 600 ml of 0.01 molar HCl is mixed with 400 ml of 0.01 molar H2SO4. So here I have taken strong acid, 1 HCl, 1 H2SO4. I have taken both possibilities so that you will not forget to multiply by 2, because H2SO4 contain 2. So let us see here what they are saying. They are saying that 600 ml of 0.01 molar HCl is mixed with 400 ml of 0.01 molar H2SO4. Okay, after mixing, so we will check either its concentration, given concentration is greater than 10 to the power minus 6 or less than. So 0.01 means it is 10 to the power minus 2, which is greater than 10 to the power minus 6. This is also minus 2, which is greater than 10 to the power minus 6. So no stress, no need to add 10 to the power minus 7 here. So let us find out mole here. So this mole will be molarity into volume in liter. Molarity is how much? 10 to the power minus 2 into volume. Volume how much given, bacha? 600 ml. So I will multiply with 10 to the power minus 3 to make it liter. So how much it will become, bacha? 600 into 10 to the power minus 5. So from here I can say mole will be equal to 6 into 10 to the power minus 3. Okay. Now let us find out mole from here. You try by your own. From here, mole will be equal to molarity into volume in liter. What is the molarity? 10 to the power minus 2. What is the volume? 400 ml. So 400 ml multiply by 10 to the power minus 3 to convert into liter. Then here it will come 400 into 10 to the power minus 5. So it will come 4 into 10 to the power minus 3. Here we have calculated our mole. After calculating mole, star point, here it is H2SO4, bacha. So total mole here will be 4 into 10 to the power minus 3 into 2. Will multiply by 2, H2. So 8 into 10 to the power minus 3. Now let us calculate the total H ion. So what is the formula for the mixture? Total H ion is equal to total mole by total volume. So how much total mole we are getting? 6 into 10 to the power minus 3 plus 8 into 10 to the power minus 3 divided by total volume 600 plus 400, 1000 ml. So multiply by 10 to the power minus 3. So minus 3 if you will take common, it will become 6 plus 8, 10 to the power minus 3 by 1000 into 10 to the power minus 3, minus 3, minus 3 gone. From here I will get my H plus ion concentration as 14 by 1000, that is 14 into 10 to the power minus 3, right? So I have got my H ion concentration as 14 into 10 to the power minus 3. Now we will calculate our pH. So pH will be equal to minus log H ion. I have told you whenever it is in multiplication, this 3 will come here and it will become minus log 14. So 3 minus log 14 I don't know. So how I can write down log 14? I can write down it as 7 into 2. So it will become, so I am solving it here. So log 14 will be equal to log 7 into 2. Log 7 into 2 I can write down log 7 plus log 2. Log 7 will be around 9, means I can say like 0.82 plus log 2 will be 0.3. It will come as 1.12. Okay, so log 14 value, how much it is coming? 1.12. So 3 minus 1.12 you will do, how much it will come? Calculate and find out your answer. Anyway, it is a strong acid, pH should come less than 6 only. Calculate and tell me fast quickly. Yeah, how much it is coming? 1.88. Okay, so I hope you have understood how to calculate the pH for mixture. Okay, so whenever mixture you are seeing, you find out what type of mixture it is, strong acid or strong base or both combined together. So whenever it is acid, we will see concentration more than 10 to the power minus 6, less than 10 to the power minus 6. Okay, as it is a one shot, so I can't give you the question on each and every cases, right? You have to practice it by your own. Clear? So now let us see the next case, pH mixture of strong acid, strong base. Okay, if strong acid, strong base is given, same way one question is solved for base also. For base what we will do, instead of H ion we will calculate OH ion, instead if calculated OH ion we will calculate POH ion, and from POH ion we will calculate our pH. Okay, and if you need a lot of practice, so I will upload the DPP series also, I will upload the PYQ session also. Practice all the questions, I will upload on the YouTube, you practice. If I will solve here all the questions, the video will become too long. Clear? So it will be difficult for you to revise. Okay, let us see the next case. So how many cases we have seen till now? We have seen strong acid only, then we have seen strong base only, then we have seen the mixture of strong acid, then we have seen the mixture of strong base. Now we are going to see fifth condition, that is the mixture of strong acid, strong base. Okay, so note down next case 5. Case the third was already into 2 cases, so directly I am writing fifth case, that is mixture of strong acid plus strong base. Mixture of strong acid plus strong base. Okay, now here again we have 3 cases. Let's say for example, here I am taking acid, molarity is let's say M1, volume is let's say V1. Here I am taking base. Okay, so let's say molarity is M2, volume is V2. So from acid what I will get? H ion concentration. From base what I will get? OH ion concentration. That is clear. Now depending on the concentration of H ion, OH ion, only we will use the formula. Either we have to calculate H ion or we have to calculate overall OH ion. How we will decide it? By seeing the concentration. Let's say in this the first case, if let's say your H ion is equal to OH minus ion, in that case what will happen? The pH will become equal to 7. The solution will become neutral. Are you able to understand? If in a question it is given H ion, OH ion is equal, then we will say the solution will be neutral, pH will be 7 without any stress. What can be the second case? Yes, very good. The second case can be if let's say H ion is coming more than OH ion. If H ion is greater, means the solution will be acidic without any doubt. And if the solution is acidic, pakka, pH will be less than 7 without any doubt, right? Let's say the case third. What can be the case third? Yes, you think by your own. The case third will be OH ion becomes greater than H plus ion. So if OH ion will become more, what will happen? The solution will become basic. When the solution will become basic, means pH will become more than 7. Okay, all of you please note down. Okay, if H ion is more, what you will calculate? We will calculate net H plus ion. If OH ion is more, what we will calculate? Net OH minus. So when net OH minus will come, means we will calculate POH and then we will calculate pH. Directly you can't calculate the pH, right? This again and again I am repeating because you will make mistake in your exam. Clear? Now let us solve one question. Okay, fine. So let us solve this question. So you will get a conceptual clarity of the entire mixture of strong acid and strong base. Not a single question will be asked more than that. Each and every cases I have discussed in this question. Let us see here. The first question is saying 1 liter 10 to the power minus 3 molar HCl. Next is 0.1 liter 10 to the power minus 2 molar NaOH. Okay, so how we will solve this question? 1 liter 10 to the power minus 3. So what will be mole here? Mole will be equal to molarity into volume, and H ion is also 1. So 1 into 10 to the power minus 3 into 1. Here mole will be 10 to the power minus 3. Here I will calculate it. So okay. Moles of HCl, molarity into volume in liter into number of H ion. So HCl, so 1 H ion only. Molarity is 10 to the power minus 3. Volume is 1 liter and 1. So moles of HCl I am getting 10 to the power minus 3. No doubt, fine. After that, let us see here NaOH. Moles of NaOH. So moles of NaOH also molarity into volume. Molarity is 10 to the power minus 2. Volume is 0.1 liter, that is coming 10 to the power minus 3. From here it is clear the moles of HCl and NaOH are equal. I have told you, remember the first case, when H ion concentration is equal to OH ion concentration, then directly I will say here that pH is equal to 7, the solution is neutral. The solution is neutral. Fine, it was the first case. Now let us solve the second case. You try by your own. Okay, so the first case, let us calculate moles of HCl equal to molarity 10 to the power minus 3 into volume 1 liter. HCl is 1, 10 to the power minus 3. Now here moles of NaOH base is equal to 2 into 10 to the power minus 3. NaOH, 1 OH only, we are getting 2 into 10 to the power minus 3. Who is greater here? NaOH is greater. NaOH is greater. So OH minus is greater than H plus. So means pakka the solution will be basic. So OH is greater. So what I will calculate here? Net OH. What I am going to calculate here? Net OH. How to calculate total OH, total H ion in the mixture? Net mole by net volume. Net mole by net volume. Okay. So here some H ion will react with some OH ion. So who is greater? OH is greater. So OH concentration minus H concentration divided by total volume. How much bacha? 2 liter plus 1 liter, 3 liter. How much it will come? 10 to the power minus 3 you will take common. 2 minus 1, 1. So it will become 10 to the power minus 3 by 3. 1 by 3 it will come 0.33 something. So I can say from here our OH ion will become 0.33 into 10 to the power minus 3. I can write down as 3.3 into 10 to the power minus 4. I have got OH. So from OH I can't directly calculate the pH. From OH what I can calculate? POH. So I will calculate POH here. POH will be, I have told you, whenever multiplication power will come here, 4 minus log 3.3. Okay. So I know that 3.3 means log 3 value will be around 0.5. So it will be little bit greater than 0.5. Okay. So POH I can say 4 minus, let's say 0.5 I am saying. Okay. So here POH will be how much? 3.5. So pH will be how much? 14 minus 3.5. Okay, it will come more than 7, basic solution, right? Now let us solve the third case. Calculation and all you do by your own. My entire thing is to teach you how to solve. Let us see the next question. Here the mole of HCl will be equal to molarity 10 to the power minus 3, volume 2 liter into HIN 1, HCl 1 HIN. So 10 to the power 2 into 10 to the power minus 3. What we are getting? 2 into 10 to the power minus 3. Now, moles of NaOH. Okay, what is molarity? Minus 3 liter, 1 liter NaOH 1. So, here we are getting 10 to the power minus 3. Here who is more? HCl, acid is more. Okay, so from here I will say the moles of HCl is more than moles of OH. So this solution is acidic solution. So how we will calculate? Here we will calculate HIN. Here no need to calculate POH and all. HCl is more. So net solution HIN will come. So HCl will be equal to HIN concentration 2 into 10 to the power minus 3 minus 10 to the power minus 3 divided by total mole, how total volume 2 liter, 1 liter, 3 liter only they have given. So it will come 1 by 3 into 10 to the power minus 3. So from here I can say HIN is nothing but 3.3 into 10 to the power minus 4. So from here directly we will calculate because it is HIN. So the 4 power will come here minus log 3.3. So it will come 4 minus 0.5 something. So approximately 3.5, okay, less than 7. So this is how we will solve the case of pH mixture, right? If it is strong acid, strong base, equal, then pH will come 7. If acid is more, calculate HIN. If base is more, calculate OHIN. And if calculating OHIN, we will calculate POH and then we will calculate our pH. Fine? So finally we have finished here our strong acid and base. In that what we have studied? Strong acid calculation, strong base calculation. Then we have studied mixture of strong acid, mixture of strong base and then mixture of strong acid, strong base. Now we will study about the weak acid. Weak acid is little complicated at comparison to strong acid and base. Okay, let us see here. So whenever we are talking about weak acid, we define it with the help of one law that is known as Ostwald dilution law. That is known as Ostwald dilution law. Okay, so I am writing here Ostwald dilution law. What does it say? So I have told you weak acids are weak electrolytes. Weak electrolytes undergo partial dissociation. It undergo partial dissociation. Partial dissociation, it means degree of dissociation alpha will be less than 1. So what does the dilution law says? The Ostwald dilution theory says that whenever we will increase the dilution. Dilution means whenever we are adding water. Dilution means we are adding water. So whenever we will increase the dilution, concentration will decrease and the degree of dissociation will increase. So at infinite dilution, our degree of, when we are doing dilution, alpha increasing, so at infinite dilution alpha will increase. How much it will increase? Alpha will become 100% dissociation. So at infinite dilution alpha will become 100% dissociation. This is all about Ostwald dilution law. Clear? Okay, now let us solve. Okay, for weak acid. So I am writing here any weak acid. I have already taught you now how will you identify weak acids. Okay, let's say HA. So HA will dissociate as H plus and A minus, no doubt. Let's say initially at T equal to 0, the concentration of acid is C and H plus and A minus will be 0, 0. At let's say T equilibrium, we are saying that degree of dissociation is alpha. C alpha is dissociated. So initial was C and from this C how much dissociated? C alpha. So here also how much concentration? C alpha. Here also how much concentration? C alpha. Right. Okay. So from here I can say that Universal formula, H ion concentration is equal to C alpha. H ion concentration is equal to C alpha. Star formula, universal formula, always applicable for weak acid. Okay. Next, I can say Ka. What is Ka? Dissociation constant of weak acid. Dissociation constant of weak acid is a K equilibrium only. Now, how to write down Ka? Product by reactant. Who all are in product? Concentration of H plus and A minus divided by product side what we have HA. Fine. Okay. Now you tell me H plus is C alpha, A minus concentration C alpha, HA concentration C minus C alpha. From here if I am taking, so it will become C square alpha square. If I am taking C common here, 1 minus alpha. So C and C gone. From here Ka how much we will get? Tell me fast. C alpha square by 1 minus alpha. Ka how much we will get? C alpha square by 1 minus alpha. So here I am writing 2 star point for weak acid. The universal formula, always applicable formula is first H ion equal to C alpha and second Ka equal to C alpha square by 1 minus alpha. Always applicable. But for easy calculation, what we do? We neglect alpha sometime. For easy calculation, what we will do? We will neglect our alpha sometimes. So, when we will neglect the alpha? So, we will have again two cases to make your calculation easy. Let us see here. Okay, two cases. If I am saying the alpha value is very less than 0.1, alpha value greater than or equal to 0.1. What are the two cases? Alpha very less than 0.1 or greater than or equal to 0.1. So when it is very less than, then what was the formula for Ka? Ka was C alpha square by 1 minus alpha. So if alpha is very less, I can ignore this alpha or not? I can ignore this alpha. So from here I can say Ka will be equal to C alpha square. So from here what I can say? Alpha will be equal to under root Ka by C. Alpha is equal to under root Ka by C. Are you able to understand? Okay. Alpha square, so alpha equal to under root Ka by C. Now we have seen H ion. H ion was equal to C alpha. Can I keep this alpha value here? So H ion will become C under root Ka by C. If this C will come inside, will it become under root Ka into C? How it will become? Under root Ka into C. Now, from here, can I calculate the pH if I have got H ion for weak acid? pH equal to minus log H plus ion. And what is the value for H plus ion? Under root Ka into C. So, our formula will be pH equal to minus log under root Ka into C. Under root means power half. So, one more formula of pH will come, that will be half pKa minus log C. What is the formula for pH for weak acid? Half pKa minus log C. So in our strong base, strong acid, it was very easy. Calculate H ion and put it into pH and find out the formula minus log H ion. But yeah, for weak acid, as the dissociation is not 100%, we have to find out alpha H ion, then only pH using these formulas. Clear? Now, if we have alpha more than or equal to 0.1, then we can't ignore, we can't ignore that alpha. What we will do? C alpha square by 1 minus alpha. From here, we will calculate our alpha, making this quadratic equation. We will make a quadratic equation and we will solve our alpha. After solving alpha, we will use our universal formula H plus equal to C alpha. Once I have got our H plus, then we will find out pH equal to minus log H plus. Are you able to understand how to solve? So, whenever alpha given question will be more than 0.1, in that case we will find out our alpha using the quadratic equation and then we will solve and calculate. Fine. Okay, fine. Now let us do a quick revision of the weak acid concept. So whenever you will see weak acid, how will you identify? COOH will be there, organic acids. These are weak acids. So whenever you will see weak acid, the first step is to calculate alpha. The first step is to calculate alpha. And what is the universal formula to calculate alpha? Alpha equal to under root Ka by C. As soon as you have calculated, then you will see alpha value is less than 0.1 or equal to or more than 0.1. If it is less than 0.1, then no stress. We will take our alpha as under root Ka by C. Then from alpha we will calculate our HI, and HI equal to C alpha. If you don't want to use this formula, K and C is given, you use this formula under root K into C. After calculating HI, directly you use your universal formula of pH equal to minus log H plus ion. And if you don't want to calculate HI, directly you can calculate the pH using, because K and C will be given, directly we can use half pKa minus log C, or minus log under root Ka into C, whichever formula you want you can use and calculate. But if alpha is more than or equal to 0.1, then what we will do, we will find out our new alpha. How? Minus Ka plus under root Ka square plus 4Kac by 2C. Okay, after calculating alpha, we will use this alpha and H plus calculation. H plus equal to C alpha. So C alpha, you only remember the alpha formula. I have told you now, solve a quadratic equation and do. So here itself I have solved quadratic and I have written a formula. If you want, you remember, otherwise it is not required. You know how to solve quadratic equation. Those students who are weak in mathematics can't solve quadratic equation, remember this formula and only remember alpha. Minus Ka plus under root Ka square plus 4Kac by 2C. Once you have done with alpha, calculate C alpha using HIN formula, and if you know HIN, you use pH equal to minus log HIN and calculate. No need to mug up all these three formulas. Let us solve one question. Okay, so the question is calculate pH of 0.1 molar. So here HIN concentration is 10 to the power minus 1. CH3COOH. COOH means what? It is weak acid. Weak acid means, don't say ma'am 10 to the power minus 1. So pH what? No, we will not say. It is a weak acid. That is why in a corner they have given Ka also. If you don't remember weak acid, weak base, at least you remember Ka, Kb, and Ka, Kb given means weak acid, weak base. So if weak acid, what is the first step? Calculate alpha. That is under root Ka by C. Alpha will be equal to under root Ka 10 to the power minus 5 by 10 to the power minus 1. It will go upside. Alpha will be equal to 10 to the power minus 4. So alpha equal to 10 to the power minus 2. That is 0.00. That is alpha equal to 0.01. Now see here, 0.01 is very less than 0.1. So it's a simple question. It's a simple question. What I will do here? I will calculate HIN. HIN equal to C alpha. Concentration was how much? 10 to the power minus 1, and H alpha is how much? 10 to the power minus 2. That is our 10 to the power minus 3, and we know if HIN pH is the power, pH will be 3 here. Easy or not? Very easy. I am not using that half log pK formula and all. I am not using. I am using our general. Remember one formula and apply it everywhere. Okay. Even though if you want to solve using formula, let us see how we will solve. What was the formula? pH equal to half pKa minus log C, half pKa. So Ka is, from here, Ka is 10 to the power minus 5. So pKa will be our 5. So I will say here 5 minus log C. C is how much? 0.1. That is 10 to the power minus 1. So from here half 5 minus. So I am solving here log 10 to the power minus 1. Minus will come here. It will become 1 into log 10. Log 10 is 1. So 5 minus, and here it is minus 1 and it is minus 1. Minus will become plus. 5 plus 1, 6. 6 by 2. How much we are getting here? 3. So either you solve using this formula or else you solve using this method. Okay. Anything will be fine. Okay, fine. So let us see here the mixture of weak acid with weak acid mixture. So let us take here weak acid HA and here weak acid HB. Here alpha 1 degree of dissociation, here alpha 2, because partial dissociation will be there because it's a weak electrolyte. Let's say here Ka1 dissociation constant, here Ka2. Let's say here concentration C1 molar and here concentration C2 molar. So from here the first one, the ratio of alpha 1 by alpha 2 will be equal to Ka1 by Ka2. Next second, how will you find out this? Here alpha value, alpha 1 will be equal to Ka1 by Ka1 C1 plus Ka2 C2. Same way, what will be here alpha 2? We can calculate Ka2 by under root Ka2 C2 plus Ka1 C1, right? Okay, so I will give you the summary of the entire formulas for weak acid and weak bases. Okay, let us see here. So here we have our mixture of weak acid. This is the concentration. So alpha 1 by alpha 2 is equal to Ka1 by Ka2. Alpha 1 just now I have told you will be equal to Ka1 by under root K1 C1 by Ka2 C2. Alpha 2 will be equal to under root Ka2 by under root Ka1 C1 plus Ka2 C2, note down. And what will be H ion? H ion concentration for mixture. This is important because pH only they will ask you, right? So what is the H ion concentration for weak acid? Under root Ka1 C1 plus Ka2 C2. And next the fifth concept, relative strength of two weak acid is C1 alpha 1 by C2 alpha 2. Okay, so let us solve one question. I am saying here, let's say for example 0.3 molar CH3COOH, which is a weak acid. Let's say I am saying here K1 equal to 10 to the power minus 6. Okay, and here let's say it is mixed with any other case. Let's say for example I am saying minus 6, you take it as minus 7. Okay, for easy calculation, minus 7. Now here let's say for example I am taking here 10 to the power minus 3 CH3COOH, and here Ka2 we can take as 10 to the power minus 5, and for this weak acid mixture let us calculate the pH. So what I have told you, for weak acid mixture we will calculate our H ion. How we will calculate our H ion? Ka1 C1 plus Ka2 C2. Okay, let us solve fast. So Ka1 10 to the power minus 7 into 0.3. Can I write down at 3 into 10 to the power minus 1 plus Ka2 10 to the power minus 5 into 10 to the power minus 3. Okay, now here, okay, so it will come 3 into 10 to the power minus 8 plus 10 to the power minus 8. Okay, 1 into 10 to the power minus 8. So here can I say 10 to the power minus 8 as a common, so it will become 3 plus 1. So from here it will come under root 4 into 10 to the power minus 8. So 4 into 10 to the power minus 8, it will come out of the root and it will become 2 into 10 to the power minus 4. So our H ion is coming 2 into 10 to the power minus 4. So I have told you the trick to find out the pH. Oh, don't use the weak acid and all formula, no? It's difficult. Just we will use our common formula, pH equal to minus log H ion. So I have told you whatever is power will come here minus. This number will become as log, minus log 2. So 4 minus log 2 0.3, it will come around 3.7. Easy. So this is how we will calculate our pH of mixture of weak acid solution. So here we have finished our weak acid cases. Now we will see weak acid. This all condition was for monoprotic. It was for monoprotic. Already I have taught you what is monoprotic, diprotic. Now we will study about the polyprotic. If so many dissociation is happening, now in that case how we are going to solve. Okay, so next we will see pH of polyprotic acid. What we will see? pH of polyprotic weak acid. So polyprotic, I have already told you, polyprotic means what? More than one H ion. So 2 means diprotic and more than 2 tri-tetra. These are known as polyprotic. Okay, let us see one example, that is H3PO4. Okay, so here H3PO4. Okay, let us release H plus ion. So what will be remaining here? H2PO4 minus. Okay, so for this, let's say our dissociation constant of weak acid is Ka1. Now here H2PO4 minus. So let us take H ion from here. What I will get? HPO4 minus 2. Let's say dissociation constant here is Ka2. Next HPO4 minus 2. Let us dissociate one more H ion. So we'll get here PO4 minus 3. This is our Ka3. Here the dissociation constant is Ka3. Clear? Okay, now so there is a very like it's confusing, right? Ka1, Ka2, Ka3. Which Ka1 will decide the pH? Which Ka will decide our H ion concentration? So what we will do in this case, see here. So it is difficult. It is difficult to remove H ion from the minus charge. It is very difficult. As soon as you are removing H ion, we are getting negative charge. Slowly it is becoming very difficult to remove H ion. So I can say Ka2 is very less than Ka1, Ka3 very less than Ka1. So here what we will do, as a star point you write down, don't confuse after seeing polyprotic acid. Ignore everyone and consider the Ka1. Always the first one we will consider. We will ignore everyone, and we will only consider Ka1. We will ignore Ka2, we will ignore Ka3. So now we know for weak acid how to calculate H ion. H ion is equal to C alpha. C alpha means we can say here under root Ka into C. Okay, so from here we will calculate our, so which Ka we will take? Ka1 I will take. Now I am considering only the first dissociation constant, Ka1. If I know H ion, we can calculate pH using minus log H plus. Easy or not? Very easy. So here we have finally finished everything about pH calculation related to acid and bases. Weak acid, strong acid, weak base, strong base, everything we have studied here. Okay, now let us see salt hydrolysis. Now we will study about the salt. Okay, let us see here. Okay, so write down next topic, salt hydrolysis. Salt hydrolysis. So as I am saying you salt hydrolysis, before I start salt hydrolysis, you should know what is salt and what are the types of salt we will study in this chapter. So salt means we all know acid plus base, and on the type of acid and base we have different type of salt. Let us see here. If we can have salt of weak acid plus weak base, we can have salt of strong acid plus strong base, then we can have salt of strong acid plus weak base, or we can have salt of weak acid plus strong base. Okay, so what are the four types of salt we will study? Strong, weak, strong, weak, strong. Clear? Okay, so let us see one example. If I am saying weak acid, weak base, what can be one example? I can take example at CH3COO NH4. So now you tell me CH3, so if you will break it, CH3COO minus and NH4, anionic part, cationic part. So from where CH3COOH have came? CH3COOH has came from CH3COOH, which is a weak acid, and from where NH4 have came, it has come from NH4OH, which is also weak base. So this is how, if a salt is given, break it and then find out from which acid or base it has came. Accordingly, you can analyze the acid base nature, that is salt nature. Okay, let us see one next example, strong acid and strong base. Okay, we all know very common example I am going to write here, NaCl. Okay, now tell me, Na would have come from NaOH, which is a strong base, right? And plus Cl would have come from HCl, which is a strong acid. So I hope you are able to analyze, right, which salt is coming from which type of acid and base. Okay, let us see strong acid and weak base. Strong acid, so I can say HCl, and weak base, let us take NH4OH. So one example I can write down here, NH4Cl. Okay, so now tell me, NH4 would have came from NH4OH, which is our weak base, plus HCl, that is our strong acid. Are you guys able to understand? Are you guys able to analyze which type of salt is coming from which type of acid and base? It is very important to analyze, then only we can use our formula. Okay, next let us see one example of weak and strong base. Strong base, let us take NaOH. Weak acid, let us take CH3CO. So I can write down one example, CH3COO Okay, so CH3COO would have came from weak acid CH3COOH plus strong base NaOH, right? So whenever any salt is given, the first step, the very first step is break that salt. What is the first step? Break that salt. When you will break that salt, you have to do the next step, that is you have to analyze that salt is the result of which type of acid and which type of base. Strong acid, strong base, weak acid, weak base, strong acid, weak base, or weak acid, strong base. Then only we can, if we are able to understand this, then only you can do hydrolysis question, then only you can understand which formula demands which question, or which question demands which formula. If you are able to understand this, ionic equilibrium is very, very easy. Okay, now let us understand about the hydrolysis. So what do we mean by hydrolysis? Hydrolysis means reacting with water. Hydrolysis means reacting with water, and here we are going to study about the salt hydrolysis. I am taking one example, and this will be our case 1. This will be our case 1. I am saying, let us take here Cl minus. Okay, Cl minus, an ion would have come from a strong acid, that is HCl. Cl minus, if we are reacting it with water, what will happen? It will take H plus ion, it will become HCl and it will give OH minus. Now HCl is a strong electrolyte, then again this HCl will undergo 100% dissociation. So again it will break as H plus and Cl minus. So will Cl minus react with water actually? No. So from here under case 1, write down one star point, that strong acid plus strong base salt do not undergo hydrolysis. Do not undergo hydrolysis. Very, very important. So whenever you will see strong acid, strong base salt, strong acid, strong base salt, it will not go under hydrolysis. If it will not undergo hydrolysis, what we will say? pH is governed by whom? Water. So if strong acid, strong base is not undergoing hydrolysis, it means who will govern pH here? pH will be governed by water. So means I can say, whenever you will see salt of strong acid, strong base, we will say pH equal to 7, and the solution will be neutral, and the solution will be neutral. Clear? Note it down fast. So also we can say here this case 1 is no hydrolysis case. This case is no hydrolysis case. Okay, note down quickly. Okay, now let us see the second case. Note down case 2. Note down case 2. What can be the case 2? Anything you say. Let's say weak base plus strong acid. Weak base plus strong acid. Weak base, let us say I am taking NH4OH, and strong acid I am taking HCl. So when I will react a neutralization reaction, what I will get? NH4 plus Cl minus. This is our salt of weak base and strong acid. Weak base and strong acid. Okay, so here we have NH4 plus cation, and this cation is from weak base. Cl minus anion, and it is from strong acid. It is waste, right? Because just now I have told you strong acid, strong base do not undergo hydrolysis. So who will undergo hydrolysis? Cationic part will undergo hydrolysis. So the name will be cationic hydrolysis. The name will be cationic hydrolysis. So cation is undergoing hydrolysis. What is remaining here? Strong. Who is strong here? Acid. Who is strong here? Acid, HCl. So what will be the nature of the solution? Acidic nature. What will be the nature of the solution? Acidic nature. This is very simple. Now, strong acid, so strong will only govern the reaction, right? So strong acid means strong will govern the solution. Strong acid means the solution nature will be acidic, okay? And weak acid means cation. Cation is undergoing hydrolysis, so it is cationic hydrolysis. If it is acidic nature, so pH will be less than 7. Any doubt? No. Note down. Okay. Let us see the case third. What is our case third? Our case thirds, tell me what we can say. Last time we have taken weak base. Now here we can say weak acid plus strong base. Okay, which example we can take? Weak acid, let us take CH3COOH. Strong base, let us take NaOH. So what we will get here? The salt will be CH3COO and A. When we will break it, we will get here CH3COO minus and Na plus. Sorry, actually I am not well little bit today. So CH3COO minus and Na plus. So Na plus is coming from strong base, CH3CO minus is coming from our CH3CO minus is coming from our weak acid. I have told you strong acid, strong base do not undergo hydrolysis. Reason already clear. Okay, weak acid will undergo hydrolysis. It is anion. So which hydrolysis? First question, it will undergo anionic hydrolysis. Okay, who is strong here, acid or base? Base is strong here. So what will be the nature of the solution? Basic nature. What will be the nature of the solution? Basic nature. If the nature is basic, so pH will be pakka more than 7. pH will be pakka more than 7. Okay, note down fast. Now let us see the last case. Okay, what was our last case? Case 4. What was our last case? Case 4. Case 4 was weak acid plus weak base. Very good. Okay, so weak acid, let us take CH3COOH plus weak base, let us take NH4OH. So what we will get here? CH3COO and H4. So when we will break it, we are getting anion as CH3COO minus, cation as NH4 plus. So this is also weak acid and this is also coming from weak base. It means both will undergo hydrolysis. Both will undergo hydrolysis. Then how we will decide the pH? Who will, both are weak. Who will decide the pH? So let us see here. Who will decide our pH nature? Okay. So from weak acid I will get H ion. Okay. From here we will get our OH minus ion. Here Ka given, so we will calculate pKa. Here Kb will be given, so we will calculate our pKb. We know for weak acid we calculate Ka and for weak base we will calculate Kb, right? So here I am writing the three cases. If pKa is more than pKb, then I will say pH more than 7, case 1. Okay, what will be the second case? The second case will be pKa less than pKb, then I will say pH less than 7. What is the third case? When I am saying pKa equal to pKb, then I will say pH equal to 7. Then what I will say here? pH is equal to 7, right? So all the four cases are clear. When we will have anionic hydrolysis, when we will have cationic hydrolysis, okay, when no hydrolysis will be there, when both hydrolysis, when both are going under hydrolysis, weak acid, weak base, means our pKa, pKb concentration will decide the pH. Okay, now I have written the formula. Let us see the summary of the entire formula. So this is the summary of the formula for salt hydrolysis. So if salt is given, what is the first step? To analyze which case it belong, what type of salt it is. So strong acid, strong base, weak acid, strong base, strong acid, weak base, or weak acid, weak base. KH is hydrolysis constant. H here is degree of hydrolysis similar to alpha. Okay, so strong acid, strong base, I have told you no hydrolysis, pH will be 7, neutral. Okay, if we are saying weak acid, okay, weak acid means we will talk about Ka, so KH formula will be Kw by Ka. Formula is same. Okay, here we are taking weak base, so Kw by Kb, and here both are weak. So what will be the formula? Kw by Ka into Kb. Very simple. It will look, it is looking very difficult, but it's very simple. So repeat with me. Remember here itself. Tell me fast, quickly. When we are talking about KH, if it is strong, strong. Okay, no hydrolysis, no KH. Okay, fine. pH will be 7. If I am saying it is weak acid means KH will be equal to Kw by Ka. When I am saying weak base, so it will be Kw by Kb. When I am saying both are weak, then we will say Kw by Ka into Kb, Kw by Ka into Kb, right? Kh is clear. Now let us see H. H is again very simple, same formula everywhere. What is the formula? H equal to under root kh by c, h equal to under root kh by c. Here h equal to under root kh, h equal to under root kh. Here important star point for weak acid, weak base, H degree of hydrolysis do not depend on concentration, do not depend on concentration. Can you see it? It is not depending on the concentration. Now you see here the pH formula, and we know now KH for a weak acid, Kw by Ka, okay, KH, Kw by Kb, right? Okay, now let us see pH. So pH formula is also very simple. When both are strong, pH was 7, no tension. When weak acid is there, remember when weak acid, plus sign we will use in the formula. Weak acid, plus in the formula, and weak acid, so pKa will come in the formula, right? So what will be the formula? 7 plus half pKa plus half log C. Weak acid, so plus, and weak acid, so pKa will come, right? Okay, let us see here weak base. So when I am saying weak base, so weak acid plus, so weak acid minus will come, and pKa will become pKb. Very simple. You tell me fast, quickly. 7 minus half pKb minus half log C. Now here when I am saying the last case, weak acid, weak base, weak acid, weak base. So 7 plus half pKa minus half pKb, 7 plus half. So when both are weak acid, weak base, both are weak. So I will take pKa and I will take pKb, and I have told you for weak acid plus. So pKa before plus and pKb before minus. Like this, if you will remember, you will never ever forget. You will never ever get confused. Fine. Okay, and nature of the solution, acidic, basic. Okay, so 3 cases I have told you already. pK more, pH more, pK less, pH less, pKb equal, pH equal to 7. Right? Note it down fast. Now let us solve some questions on the salt hydrolysis. Okay, the highest pH value. So let us see NaCl. Do we have HIN? Do we have OHR? No, it means it is salt. If it is salt means we will check which type of salt. So NaOH, it is strong base. HCl, strong acid, means strong acid, strong base do not undergo hydrolysis. pH will be 7. NH4Cl, NH4Cl, NH4 means weak acid, NH4Cl, NH4OH means it is weak base plus HCl, strong acid. So strong acid, acid only we will consider. So pH will be less than 7. Okay, weak base means cationic hydrolysis. Then next is CH3COO and Na. CH3COO Na means weak acid plus strong base. So strong will only consider. So here we will get pH more than 7. Now here CH3COO and both are weak acid and weak base. So definitely it will be less than this, less than this only, right? That is our strong base, pH more than 7. So who will have the greatest pH here? 3. And if you want to remember, this is the only case which contain pH equal to 7. This is the only case which has pH equal to 7. pKa is equal to pKb in this salt case. You remember that. Okay, let us solve the next question. So the next question is 2 mole HCl plus 2 mole NH4OH in 2 liter container. So here strong acid is mixed with weak base. So pakka it is a question of salt hydrolysis. Let us write down. HCl is reacting with NH4OH. So what we will get here? NH4Cl. How much mole? 2 mole. This is also 2 mole. 2 mole will react. We will get here initially 0. Here we will get 2 mole. Okay. How to find out concentration? Mole by volume. So we will get concentration of NH4Cl, C value. So C will be how much mole? 2 mole. Volume how much given? 2 liter. That is 1 molar concentration. Now you see here who is weak. Base is weak base. So it means it is cationic hydrolysis. So which formula of pH we will use here? Which formula of pH we will use here? Do you remember for base it was minus. So we'll use here pH equal to 7 minus half log pKb minus log Okay, what was the pH formula for in the case of weak base? pH will be equal to 7 minus half pKb minus half log C. So 7 minus half pKb how much given in the question? 5 minus half log C how much you have calculated? 1 molar. So log 1, we know log 1 value will be 0. So from here 7 minus 1 by 2, 5, 2.5. So it will come around 4.5. So pH is how much? 4.5. Anyway, strong acid, so pH should come less than 7 also. It means we have done correct calculation. So I hope you have understood. And so just see the question, which type of hydrolysis they have given. Case 1, case 2, case 3, case 4. On that basis, use the pH formula and calculate it. Easy. Now let us see the last topic of this chapter, that is buffer solution. Okay, fine. So let us see our buffer solution. Okay, what do we mean by buffer solution? What do we mean by buffer solution? So whenever in any solution you will add 1 or 2 drops of strong acid or strong base, what will happen? pH will change. What will happen? pH will change definitely. Now in a solution, if I will add little bit of strong acid or little bit of strong base, pH will change. But if the pH is not changed or the change is very minimal, if the pH is not changed or the change is very minimal, then that is known as buffer solution. That is known as buffer solution. Understood? No matter when we will add strong acid, strong base, pH should change, but the pH is not changing. That type of solution is known as buffer solution. Now we will see case of buffer solution or the condition for buffer solution. So for the buffer solution, I should have weak acid and the conjugate salt of weak acid, and then conjugate salt of weak acid. What does it mean? Weak acid, let's say I'm taking CH3COOH. Okay, it should have like in a solution we should have weak acid, along with that it's salt. What type of salt? Conjugate as salt. So who is conjugate here? CH3COO minus. So we'll get CH3COONA. Are you able to understand? So weak acid plus salt is our buffer solution. Okay, so weak acid, so we will say it is acidic buffer. What type of buffer, bacha? Acidic buffer. It is acidic buffer. Okay, now let us see case 2, second composition. What will be the second composition? Weak base plus conjugate salt of weak base. Okay, so weak base I can take NH4OH and let us make one salt of it. So I can say NH4Cl. So Cl have came from HCl. So weak base as I am taking. So what type of buffer it is? Basic buffer. What type of buffer it is? Basic buffer. And the third case can be when we are taking weak acid plus weak base. That can also behave as buffer. So what are the three conditions for buffer? Weak acid plus salt, weak base plus salt, and weak acid plus weak base. Now let us see pH calculation of buffer solution. Okay, so here I have written the formula for pH calculation of buffer. If it is acidic, the formula is acidic means pKa plus log salt by acid. If it is basic, so who will come? pKb plus salt by base. It's very easy. It is very simple. Fine. Okay, so finally here we have finished our one shot of ionic equilibrium. Yeah, so this is our first one shot video for our JEE mains. Okay, so this here itself I have covered 80 to 90% of concept, most important topics, everything I have covered here. But still, now after watching this, your preparation will be around 60%. So what will be that remaining lagging 40%? That 40% is your question practice. Okay, so after watching this lecture, make a short notes. Making short note is very important. Bacha, write down all the formula on a single sheet of paper. keep it and just start revising for the next 3 months. You're more than studying, more than watching here and there video, your revision should be more, right? More the revision, more the marks, right? It's very simple, it is directly proportional. Yeah, more revision you will do, better marks you will get. So to practice question, either you can solve by your own, take JEE PYQ, NEET PYQ, start solving. Okay, and here also I will try to upload the DPP series, the NEET PYQ series, the JEE PYQ series as much as possible. After every one shot, I will try to upload the question series also. So if you are able to solve by your own, sit and solve. If not, no tension, your Nitya ma'am is there, right? So I will upload at least 200 questions per chapter after one shot series. That's all.